Okay, it is time to deploy our application. I'm gonna show you how easy it is to deploy a Rust application. Because in the end, it is everything is just a binary. So it's a single file that we need to copy to our web server and run it over there, and that's it. We don't need to care about anything else, at least for now. And at least for our REST APIs. It could be, of course, that you need to do something a lot more complex, which also requires to have some kind of assets that need to accompany your binary. But yeah, simple endpoints, simple REST APIs with no need of assets is as simple as basically copying this binary to the web server. But yeah, let's see how to make this binary. First of all, yeah, of course, we're gonna use cargo like always, and cargo build. We will just specify a flag here, which is the release flag, which tells cargo to compile everything with some optimizations for production, for example, and different also profiles. For me, yeah, this command ran really quickly, but yeah, the first time that you're trying to build with a release profile, it's gonna take some time. But yeah, the result is gonna be the same. We have now under target directory we have a folder called release, and inside this release folder we have the binary that is ready for production usage. Let's try to invoke it. So in the target directory we have release, and then a Rocket app, and yeah, that's it. Our Rocket application is now running. Of course, you notice there is no output, no debug output, no metadata here, which makes sense since Rocket was now compiled with production profile, and that means there is no development debugging output here to help you while doing development. This output helps us when building the application, but on the production web server we do not need this. Alright, and now that we have the binary, we can just copy it to the web server and start running it over there. I'm gonna use SAP to do that. Okay, so I will go to another terminal, and I will SAP this binary from target release and then the name Rocket app to my personal web server, which is called lacos.me, and then I will put it in my var ww Rocket app folder that I have already prepared on the web server. Yeah, and see, just an SCP is all that it takes. Our binary will go to a web server, and then yeah, I have another tab open that where I have already logged into my web server. Let's wait for this to finish. The SCP command, okay, it's done now. Let's switch to my web server. I'm already in the directory that we copied our binary to. See this folder, and if I ALS, I see we have the binary here. Let's try to run it. Okay, of course it is not that easy. We are missing some configuration here, especially for our database, the URL to our database. Remember, locally we had this rocket.toml file with this configuration entry in here, which told where our database is, the URL where it is, and where it can find it, how to connect to it. But we do not have this file on our web server. We could copy this file, but then that makes our deployment process a bit more, I don't know, complex. We would like to keep it simple as long as we can, with just a binary to move, nothing else. So I will not create the TOML file here. I don't want to maintain it. Instead, I'm gonna specify this environmental variable in line before running the command, like this here. So I have put this SQLite URL into Rocket databases environmental variable. Rocket knows to check this env variable, so I will prefix this as the invoking of my application with that. And yeah, see, that works already. Our application is running since there is no output here. We are not expecting any output. Remember, this is our production build. So let's try to ping our application. First of all, let's try to do this from outside the web server. So from another machine, from my local machine, I will try to curl it. Rustaceans endpoint. This is not working. Okay, let's also try it from inside our web server, and let's see if it will work from there. The IP, and then Rustaceans. Aha, okay, here it's working. We have 401, which is expected, of course, because we are missing the basic auth header. Yeah, this is our application responding. And over here, we have a log, an access log here. Rocket outputs 401 error and some also warnings. It will output. Basically now our logs became from debugging development logs to production access logs, more like it. Of course, we will have errors in case of errors, but yeah, what the application outputs is totally different from development mode. Okay, so our Rocket application is only accessible now from within the same machine. But yeah, that's actually fine. And this happens because we have specified as a URL to be this IP here, which is an internal private IP to the network of the same machine. It is not accessible from outside, then that is actually a good thing. We will see later how to make this accessible also from the public, from any machine. But for now, we don't want to expose Rocket to the wild internet. We would like to do so in a more safe way. More on this later. Now, what I would like to do is I would like to show you a nice way to manage the lifetime of our application. Because you see now, if I close the terminal here, our application will stop running. It will stop responding to any requests. So yeah, I need to keep this terminal up and running, which is not really possible and ideal, of course. Instead of invoking our application like this, we're gonna do it through systemd. Systemd is just a daemon that manages services. It is used very much into the Linux world. Pretty much all the Linux operating systems right now use systemd to manage services in the background, start, stop, restart services. We're gonna take advantage of this mechanism and basically register our application as a systemd service. Then we can use systemd to start, stop it, and retry it, start it immediately on the server boot. And yeah, cool things like this that systemd provides. Okay, so first of all, we need a file to make a file which will describe our service to systemd and how to initiate our service, how to start it, or how to maintain it in general. So I will make a new folder in here. I will call it DevOps, and in here I will put a new file. I'm gonna call it systemd.service, and I'm gonna paste the definition of our service in here. this is a way to describe what your service is, a description. I have my Rocket application as description, and under service I specify user and group. The group is like the web server of my machine, and user is my user, so I can easily copy paste the binary around. So my service will run as my user, and this group, this of course will be different for you. You can change it to use your own setup. Same for the working directory. I'm using this var ww directory. You can use something else. And then we have some environmental variables here. We just tell Rocket that the environment is the production environment, and the address, the IP address, and the port. Of course, if we would like to expose Rocket directly to the internet, we would change this to something like this. This would make sure that Rocket is accessible from anywhere, and probably the port we would change it to just 80, which is the standard HTTP port. But yeah, we don't want to expose Rocket directly to the internet, so let's do it like this. Then afterwards we have this Rocket database's environmental variable with the URL to our database, and how to execute our service. Okay, now we're gonna take this and put it in the web server. First of all, we need to log in as root, because only root can actually manage systemd and change the configuration of systemd. And then we will go in the etc systemd directory and then system. For you it might be somehow different, but this is a standard systemd path in Debian based environments. And here you can see that we have already quite a few, or maybe several Linux services. We're also gonna define our own. I'm gonna call it Rocket app.service, and then I'm gonna paste the definition that we already saw. It looks a lot better in Vim actually. And then we are just gonna save the file, and afterwards we need to register this file to systemd, or actually we don't need to register it since it is already now a file in here. This is the way to register it. But let's start it now. We can make use of systemctl command and start our service, and the name of our service is Rocket app, like we named the file name, but without the service suffix of course. So this command will now start our Rocket application. Let's make sure that it is running now. Again, let's try the Rastasians endpoint. All good. Now our application is running through systemd successfully. We should also enable the application, so this is a way to tell systemd, please start my service on system startup, and that makes sure that if our server gets rebooted, our application will start immediately. And then afterwards we can make use of all the systemd services for our service lifecycle. We can start, stop it, or restart it like this. So now this is a way to stop our service. See, now we have an error when trying to ping it. Let's start it again. And also we have a command for restarting it, like this, restart. Systemd now makes our life a lot easier. We don't need to manage environmental variables. If we want to change something, we just change the file itself, the definition, systemd definition. So if we want to add some kind of environmental variable, we'll do it here. And then afterwards we need to reload systemd and restart our application. But yeah, like that, now it means that if we have a new version of our application to publish, we will compile the binary, copy it to our server, and then afterwards basically just do systemd restart of our application, a simple command. Of course, yeah, our application is still simple, that's why this sounds so easy. If our application becomes a bit more complex and it grows and we have also other things to manage, it will become a bit of a harder thing to do, but yeah, right now it is really, really easy.